Hello, my name is João Roque, and today I want to talk a bit about section protocol and how that can be mapped in Connect IoT to do a very simple integration. So, this is a Connect IoT workflow, but let's move back a bit before jumping to this workflow and see how we can map SexGem into Connect IoT. So, SexGem protocol is very used in the semiconductor industry, a very robust protocol. You can see that it has a lot of configurations. So most of these, I would say that are kind of default cross industry, but normally I always check the technical specification to see how can this map. So they normally always specify basically all of these timeouts, the baud rates, the variable ID type, and so on. So all of this should be in your technical specification. So the automation protocol is where we configure kind of the default configurations for all of the driver definitions that will use this protocol. So they will inherit all of these parameters. In our driver definition, I chose with a very simple example. So basically I have a property, which is called status, which has an SVID of 2011. Its protocol data type is U1. So basically this means that this is the type that's known by Connect IoT. And U1 is the type of the machine. And Connect IoT behind the scenes does this translating. So it's very normal for each protocol to have kind of their own set of data types. So this is a harmonization of data types right here. Then we have our event. An event is mapping a CID, so a CID of 1000. And then we have kind of our report, which is called an event property, where we map the properties to events. So in this case of SexGem, they are nested under a specific report ID. So going back to our controller, we can see that we have an equipment event. This equipment event is mapping the status change that we saw in the driver definition. So the status change event has an output status. This output status will do two things. Will basically be used in this switch and also trigger the entity instance. This switch will basically convert this integer into a semi-10 state model. So this is very common in the industry to have a set of kind of state models or states for the machine and then another for the MES or for the other solutions, and having to do kind of this translation back and forth. Sometimes they are richer, sometimes they are richer than semi-10, most of the times they're not. Okay, and someone has to do a bit of mapping right here. Connect IoT and MES can have different state models, so we can always map all these state models in the MES, but for reporting, they should always have a correlation with semi-10. So keep that in mind. Then we call the adjust state. Adjust state will basically change the state of the resource. So for this example, I created here a simulator. So this is my SexGem simulator. I know it's not pretty, but he does his job well. And I'll start Connect IoT. So I'm using a console application, Connect IoT in console application mode, just so it's easier to see what's happening. You can see that it has connected with the SexGem simulator. If we go here above, we can see that these are our configuration settings. So these are the configurations that were used to try and connect. We are in active mode, so basically we are trying to connect with a machine, in this case a simulator. We can see, basically this is a SexGem specific flow, so we have a stream1, a function 13, where we establish the communications. We get a reply back in the F14 with acknowledge code 0. Acknowledge code 0 is normally the OK. Then we send the request online, and the machine is up and running. We also have here a part that's kind of defining all the reports. This is all done behind the scenes from Connect IoT. But nevertheless, this is surfaced. Okay, so basically, if you have a very custom lifecycle for your machine, you can also tweak this. So let's see if this works. So I'm going to say go to standby, go to productive, and let's see if the machine is in productive. Okay, it is. You can see it right here. So let's change it to another state. So I'm going to change it back to standby. Okay, you can see that the MES is being notified about these state changes. One last part that I wanted to show you, which is this is very static. Okay, so this means that for this integration, you can have multiple edge machines for sure. So you can add new controllers for H02, H03, H04, and that part will be dynamic because it will see the instance that's associated with the Connect IoT. But imagine that you have a new integration where you have to do again this state change scenario, but instead of receiving one, you receive 1,000, or you receive A, B, C, or something other than that. This is very static and will force you to have always to go here and configure this. Sometimes that's okay. So sometimes you want kind of all this version control on top of everything, and you don't want to have things a bit more dynamic. It's 100% fine, you can do that. But let's see a more dynamic scenario. Let me just turn off the event emitter for this one, so we don't get double events. And let's connect this one. So what's the difference right here? So we can see the flow is more or less the same. So basically you have an event that's a status change that's retrieving the entity that's associated with this controller and then resolving, so doing something. In the other case it was a switch, in this case it was a resolve table and then adjusting states. What's the difference here? The difference here is that we are using a table to kind of lift our state resolution. So what this means is that now I can have kind of a more dynamic way to define all of these states. So I can have it by resource type. So I can say that for the whole set of a specific resource type, these are the states. So this is the mapping. So imagine that you can bundle all of these edge machines into an edge type. I can have a resource type saying edge type, which has all of these the same state model. So you don't have to kind of be worried about this. Or for example, if you have a different resource type for a different subset of machines, you can also use the same state resolution engine. So for example, in my case, what I did was I created a smart table that allows the resolution by resource or by resource type. And then I have a mapping. So I have a mapping of machine status to semi-10 status. So right now, if I go here and I say, and just to recap, my H01 has a resource type of general. So we can see here that's general. Machine status 1 is expecting states to be standby. So right now, if I run my simulator again, and I know that status 1 means non-schedule, okay? So if I run on-schedule, you'll see that right here it says standby. Why? Because of this mapping right here, okay? This is kind of a clever way to approach this, where you can have a standardized way to manage states. So you can say that, for example, this table manages all the states in the MES for equipments. This normally it's very useful because normally people have or customers have a grouping of machines or of machine types. So they want to have a centralized way to manage all of this. And for example, if you want to change how the mapping works, because in terms of the mapping to simulate it was not correct, it is a very easy fix. So it's just going to the table and changing it. So for example, if I go to this table and I add here to saying that 1 now means productive, and if I restart this, because I need to retrieve the table again, you can see that now 1 means productive, okay? So it has its trade-offs, but I think it's a clever way to kind of address this scenario. So I hope you learned something, and thank you for watching.